Hey guys, it is your favorite time of the day. It's time for the video with Miss Kearney. Thank you all for tuning in today. We are featuring on today's show mini lesson 6, scale factor and scale models. So you can go ahead and at the top of your mini lesson, go ahead and write, this is entry number 6. And you guys at this point know my expectations. I just want to see that while you are listening to the video, you are writing down everything that I say. If at any point during the video you need to, feel free to pause and rewind and rewatch as many times as you need. So take just a moment and read your learning goals so you know what the expectations are for today. Excellent. So today we are going to be working on something called scale factor. And we're going to be solving for missing pieces like we've been doing with proportions. We're just going to be applying it to a real world application called scale factor and scale models. So let's just take a moment to talk about what in the world is a scale drawing or a scale model. So what I want you to do is right now I want you to picture in your mind when you are getting ready to build a house. Usually, what do you need to build a house? That's right, you need something called a blueprint. Someone usually sketches out what they want their house to look like. But do they actually draw the house as big as it's going to be? Do they like take a piece of paper that's the size of the house and draw the map of the house? No, that would be silly. They take all of the size of the house and they make it smaller. They scale it down so that it is proportional to the actual size. Or think about a map. When you're going somewhere and you're looking at a map, is the map of the United States as big as the United States? Oh, way no. So the map is something called a scale drawing. It is proportional to the size of the United States, but it's not as big as the United States. So maybe for like every inch on the map, that might represent 20 miles in real life. So what would 2 inches on the map represent? That's right, 40 miles in real life. So let's just get those definitions down. A scale drawing or a model is a drawing or model that is similar. And think about, we just talked about what similar figures are. Remember, similar figures are the same shape, but not necessarily the same size. They are proportional. So behind that, I'm going to put, just to remind us, similar means they are proportional to the actual size. So my map or my drawing doesn't have to be the size of whatever it is in real life. It's a proportional drawing, okay? And how they draw it proportionally is they use something called a scale factor. Scale factor is the number that you are multiplying or the ratio you are multiplying in order to make something bigger or smaller. So for example, we take the size of the United States and we decrease the size to make the map. So we use a scale factor that makes it smaller. So scale factor is the ratio that is used to increase, or we can say enlarge, or reduce a figure. So basically, scale factor is the number, and when you ask yourself how many times bigger or how many times smaller something is. So how many times bigger or smaller? So basically, you can just look at the scale factor to try to figure out, are we making it bigger or smaller? So let's talk about where in the world you see these scale drawings and models. And we've already mentioned a few. So some real world examples. We've already mentioned maps. Okay, maps are a scaled down version of the real life version. Another example would be blueprints. And for those of you who don't know what blueprints are, that's just a drawing or a sketch or the plan of a house or a car, something you're going to build. It's the plan that you're going to build, and it's a much smaller version. Now, I want you to think back to your childhood. How many people had something called Hot Wheels or Power Wheels? Like for me, when I was little, I drove in this super cute Barbie Jeep. And what's so cool is the Barbie Jeep looked like a real Jeep. It was just a very small version of a real Jeep. That is called a scale model. They took the life-size Jeep and they scaled it down to fit me. So, Power Wheels are an example. And I'm sure you guys can think of lots more examples. If you can think of any more examples, feel free to write those down now. So, in order to solve these problems, we're going to use a proportion. And it's going to be super duper easy breezy lemon squeezy. So, we are going to use this proportion. We're going to use scale over actual equals scale over actual. That is how you determine the scale factor of something. You always want to put the scale size over the actual size of the figure. So, anytime you get to a scale problem, what I want to see you do, even if you get really tired of writing it, I want to see that you write this right here. Just to help you remember, I've got to put the scale over the actual. So, now let's start with the first example so you can see just how easy this is. Take just a minute and read that example to yourself. All right, so we've got a map problem, and we've got the map of Florida, and it's saying that the distance between two cities is 10.5 centimeters. Does that mean the cities really are 10.5 centimeters apart? Probably not. That's the map drawing. So it says, what is the actual distance between them if the scale is 3 centimeters equals 80 miles? That means for every 3 centimeters on that map, that represents 80 miles in real life. So, since this is a scale problem, like I told you earlier, I'm going to write a mental note here. Just help me remember, I'm going to put scale over actual equals scale over actual. So let's set it up. So here it tells me that my scale is 3 centimeters, actually represents 80 miles. And it's saying the distance between two cities is 10.5 centimeters. So we want to know the actual distance. So where's that 10.5 centimeters going to go? That's right, it's going to go on the top, 10.5 centimeters. And I don't know how far apart they are in real life, so I'm going to put an X there. And we are going to solve these just like we've been solving them. So take just a moment to try to solve that proportion. Ask yourself, which two numbers do I need to multiply? And I'm going to multiply 80 times 10.5, and I get 840. And I'm going to divide that 840 divided by 3, and I'm going to get X equals 280 miles. So just to recap, I multiplied two numbers that were diagonal from each other, like we talked about yesterday, and we're going to divide the number that's straight across that's left out. Okay? So 80 times 10.5, I got 840. 840 divided by 3 is 280. And that's basically how you do all the scale problems. You're just going to set up scale over actual equals scale over actual. So for the next two problems, you can do that exact same thing. Now, what I want to do is I want to quickly, before we end the video, I want to skip down to this fourth example here. Okay, this one down here. Because this one is a little different. So this one says, In the scale drawing below, each side is 1.9 centimeters long. If the drawing is going to be enlarged by a scale factor of 20, what is the perimeter of the enlarged object? So basically, I'm going to come back up here and I'm going to remember that we said scale factor was how many times bigger or smaller something was. So when I see the keyword scale factor of 20, that means I'm going to make something 20 times bigger. So I've got to figure out what is 1.9 centimeters if I make it 20 times bigger. So I'm going to take 1.9 and multiply that times 20 because I'm trying to make it 20 times bigger. And I get 38 centimeters. So that means now all of my sides are 38 centimeters. So this one's 38, this one's 38, this one's 38, 38, and 38. But what did the question ask me? The question asked me for the perimeter. So we've got to take 38 centimeters and find the perimeter. And since they're all the same, I can just simply see there are 5 sides and take 38 and multiply times 5 and get 190 centimeters. So that's it, guys. That's all that we have to do for scale factor. So we just to recap, scale over actual equals scale over actual. And we learned that scale factor is the number that we're using to figure out how many times bigger something is. So it's the ratio that is used to increase or decrease. So feel free to go back and rewatch, pause the video at any time that you need to. And if you have any questions, you can ask me when you come to my station. So at this time, why don't you get started on the next practice problems and check the answer key to make sure you're on the right track. All right, good luck, guys. Love you, mean it. Peace out, rainbow trout.